Hey guys, so I got a little bit more here on this motor. I just what I've done, like with any air coil, usually put them as close to the rotor so you can get it. Best results with air coilers. And the rest of it's all the same. I got the meter here still on that one coil in the back here. So I've only tried this motor for whatever on the video there, and then after that I moved this in a little bit and maybe ran it for about 5 minutes. So I just want to do some tests here under load. So I'll probably just take that coil back there that's hooked to this here after we get it running. I'll just take this off and short that coil out. Maybe do a little bit, couple with my hand. Put some loads on it. Same thing, the scope is all the same. It's hooked up in the same spot here on the motor coils. Measuring DC voltage, or AC voltage, it's in AC. It won't work in DC unless, because it just doesn't register the waveform properly in DC. You'll get half of it. I can demonstrate that too if you guys want to see. Your meters need to be hooked up properly to measure this stuff. So turn it on. See, if the magnets were a little bit closer together, it would self-start no matter what. So it's turned all the way down as far as I can get it down. Well, to where it functions properly anyway. That's about as low as I'd run the motor. With this firing, like this frequency of these caps, I've not tried any other caps in it. I haven't done any tuning of this besides just moving this in. It's just a basic, just like a normal motor. So you can see both sides are going. Take one side off. Their side off. Kind of same as the last video. And here's the meters. So the second part of this video, I think here after I do this test to see what the loads are like, I'm going to hook up some battery banks to the outputs, take the lights out, and put like 55 volt battery banks on each one. And then I'll use the current clamps. I use one of the current clamps anyway on the input here. I'll get rid of these gauges. I'll probably keep half a voltage reading in the bottom, the current on one half of the motor. And we'll see what it does. I don't know what that's like yet at 55 volts. Usually when you try to take the voltage out at a higher voltage, like the output, it'll cause the motor to run a bit slower and it'll use a little more energy. That's always what I've seen in the past. See, this is kind of interesting. This is what I was saying here about one video. Right here. See this? That's because one of these magnets on this rotor is weaker. That's the only reason that's like that. There's only one that's like that. I know these are just cheap Chinese magnets. claim to be N52s, but they're definitely not N52s. Maybe N40 if you're lucky. I think it's up to speed here now. So I'm just gonna take note here. We're just under 150 milliamps on each one. Like just barely under it. So let's just put a little bit of a drag on it. Hasn't moved at all. So I brought it down from 80 hertz to 50-ish. And the power consumption hasn't moved. If at all, it went down a little bit because the timing is less now. So that was at 50 hertz. Let me just short it out with a coil in the back there. Direct short that coil out. It was at let's just let it speed up again. Get it back up to 80 where it was. So that's about 13 volts per battery on the input here. 13.2 probably. $150 milliamps. 145 on the gauge, on those analog gauges. So it'll be more than that when you put the current clamps on it with the scope. It's probably pulling close to, I don't know, between 3 and 400, I'm guessing. Maybe more. But current consumption doesn't change it. Like with the frequency of the rotor slowing down, that means the consumption is going down too. They're going from 80 hertz to 50 hertz. And we're almost at 80, 79. I'm going to take this off and short it out. There, direct short from that coil in the back. No change on the consumption. Just gets a little bit lumpier because the frequency is going down. Seeing that meter is not really going over 150. Right at 150, both of them. Yeah, it's not slowing down anymore either. So that's that. I'm gonna take the lights off now and gonna change this around a bit. Get some current clamp in here, measuring current on 1/2 and the voltage, and I'll have two 55 volt batteries in here. 54 to 55, 56 volts in that area. They're not, I haven't taken them down to a certain voltage. I'm just going to grab them off the shelf and put them in here. This isn't really needed anymore. I'll keep it hooked up and then I'll bring it back in the frame later maybe. I'll put those battery banks right here where the lights are. Okay, it should have it all hooked up. Let's just take a quick voltage reading of these batteries. For a reference. This one is 53.75. This one's 55.72. I don't need that. Should be able to see the frequency up there too. So here, the current, I have it set so the bottom is going to be the current coming out of the battery. The waveform should go down. Oh, what am I doing? The wrong one. So, and this is going to, the top should be the input. Well, it'll be both ways because of the settings here. Because it's EC, you know. It's not just one side. So I'll adjust it so it can fit in here. So nothing's adjusted yet. I'm going to start it up before this camera overheats. So we're set for 10 milliamp. It's for 1 millivolt setting here. That's the current right here. That's what's coming out. So now I want to see this on the output now. You can see it's only taking this right here, but you can actually see there's some current that's trying to go back in the battery from the other side of the motor, which is pretty interesting on the flyback here. They're both on now. So now when I put this, if I go like this, it should be the opposite. Going in there. Go like this one. Now move this down more. There you go. So that's 42 milliamps. Just adjusting the timing a bit. Probably going to see the speed change quite a bit, but that's just how you tune it to get your output. Now look at the current going into the output. So I've reversed this wire too to make it so it stays on the bottom. That's the opposite of what this one was. We gotta measure the other one for the input. Motor's almost stopping. See, I don't think you'll see over unity unless you get more coils in series. So I'm sure it's using quite a bit of current right now. Let's just throw a meter on here. This is going to be one of the inputs here. If I remember which way to put this. Oh, it's not bad. 100. Same as before. I haven't touched the inputs here on this, so it's still under 150 milliamps on the gauge here. This is the side that I'm measuring with the current. See what it says. So it's quite a bit less even. So yeah, we are getting over unity here by the way this one looks, but let's just put see what these are measuring here now. About 46 milliamps, 40 milliamps. I'll go to the input. Yeah, not even close to over unity. nothing like what I've shown before. Yeah, this is way less. We're almost an ampere in pulses coming out. 96 milliamps. So yeah, not even close. Or like 40 times 50, like 40 milliamps times 50. Which one am I on here? The higher this one I was measuring. I think that one had the higher voltage. So it's like almost 56 volts on that one. At 40 milliamps. Or was it almost 50? Yeah, 50, almost 55.7 some, I think it was. So they're at 95 millivolts, so that's 950 milliamps coming out of the battery. This one, that's the same circuit. See, like even this gauge is reading, see, like it almost times that by 10, and that's your real reading with these pulse motors, because it's like a pulse of energy, right? To get the real numbers, you'd have to do all the time factor and stuff, but that really doesn't factor into this, because the power current coming out of the battery it goes into the output battery at the exact same time, exact same frequency. That's why I don't concern myself with those measurements. I just go with these ones. And you see the motor's running quite a bit slower too at these higher voltages. But I did turn this down, tune this a bit. But it will run slower though. So you tune it again just like I did here. It should run a bit less than 80 though. Unless I got the timing a little better now. This one camera here on the scope's gonna overheat here soon. Yeah, I'll be putting this on some different motors with more coils. I want to see how it acts on that green rotor with the magnets that are touching each other. This one's working pretty good. If I had it surrounded with coils, it would work really good. Be getting some over unity results like that. See, this is the input on the bottom of here, and that's the output. Let's see here. I don't remember if I blew up these lights or not in this one direction. If they light both ways. Yeah, it's working, and I'm only getting one side lighting up, so don't see that feedback when there's only one side starting that's lit. really good way to measure and see if you got power going back into the source. This side's not enough to light the lights anyway. See what this one's doing. This one's the same thing. Nothing. Just power coming out, that's it. Which is good. See, there's lots you could do. This is, you can change the frequency here in the caps. I don't remember what I was using with that last video. Like with the green rotor. With the 4 coils. But just wanted to do a little bit of tuning and seeing what works here with different voltages anyway. Camera's gonna overheat here right away, but we'll see if we hit 80. Find out the RPMs, you'd have to take that frequency number 72, divide it by 8, and times it by 60. Because I think there's 16 magnets on this rotor, north-south. It might hit 75 hertz or so. It might keep going up a bit. It's using less energy though than it was with the lower. On that side anyway. Wrong side. There's 150. Well, let's just measure this again. To the 10. Made a bit of a difference. It's 13.6. That's 130 milliamps. Go back to the input. Back to the 50. It's actually less now, 750 milliamps. And 130 on the output at 55 volts. So that's getting pretty even there now with those numbers. Six times 0.13 or 55 times 0.13, 7.15 watts on the output. And we've got 13.2 times 0.75, 9.9. So 9.9 coming out and 7 running out. Going into the output battery. But that's a long enough video here, guys. Thanks for watching. Just gonna keep seeing what works best with this circuit here with this motor. I like to keep the voltage high like this because you can see it balanced out pretty good here. So, thanks for watching, guys. One more thing, I forgot to want to do a load test on it, see if the current changes, especially since I have the scope here hooked up to current clamp. I have it hooked to one of the inputs here, right here. I also have the gauge on this side. Actually brought that up for you guys to see better. So we're actually going faster now, but that could be just because I tuned it a bit. We're at 82 hertz and it's still climbing. This is about the same, 150, just a little bit less. And the measurement here is still, it's about 750 milliamps. So 75 millivolts it equals 750 milliamp pulses. So direct shorted out with that coil. So that's the current right here, which is going into the motor. This is really accurate, and it's under load now. And this is staying pretty close to the same, it's just jumping around a bit now. This barely moved. Look, it's right there. It's like nothing. For the amount of power that it's extracting out of that coil, and it hasn't moved on the input. This gauge is just trying to read, because it has more time now to actually read the real measurements, which is 750 milliamps, right? So that's why that's bouncing up like that. This is telling you the real story. It's dropped down by maybe 10 milliamps. It was about 750 before, what is it now? It's a little more than that. 82. Which is not much. So this RPM here hasn't moved. Very little, 10 milliamps about. hardly any draw on it when you put a load on it. And it is under a load too with the fan too. It's kind of interesting. I'd like to see what that does with some different frequency caps. But that's enough, guys. Like I said, thanks for watching.